Hello and welcome back. Today we're talking about the confusion matrix and different accuracy ratios. So let's imagine that we are building a model that will predict based on images, X-ray images of lungs, whether there is cancer or not in the lungs. So we're going to build a matrix here on the left. On the top, we have the prediction of our model, and it can be negative, no cancer, or positive, yeah, there is cancer. And then on the left, we have the actual state of things. Is it negative? There is no cancer. In reality, there is no cancer. That person doesn't have cancer. Or positive, that person does have cancer. So, and once we cross these rows and columns, we'll have 4 different cells. The top left one is called the true negative. And by the way, before we go into this, the positioning of these cells depends on the source that you're looking at. So some places draw confusion matrix one way, other places other way. So, and I'll link to an article about this at the end of this tutorial. So back to our true negative. So the cross between negative and negative is a true negative, meaning the model predicted that there is no cancer, and in reality, that person doesn't have cancer. So in this use case, it's a great result for the person that's in question. Now, the bottom right is called a true positive. The model predicted that this person has cancer, and in reality, they also have cancer. And while this is not a great result at all for the person in question in this model, at least they know that they have cancer and they can now address it with their doctor and potentially, hopefully, get treatment. Now, in the top right, we have something that's called a false positive. The model predicts that the person has cancer, but in reality, they don't have cancer. And this is called a type 1 error. And this is a problem because even though for the person in question, it's a relief that they don't have cancer, imagine the emotional stress and suffering that they will go through when they're told by the model that they have cancer, even though they don't have to go through this stress and suffering because they don't actually have any cancer. So it would be much better if the model told them the correct answer, they made the correct prediction that they don't have cancer. So it would be much better if the model gave them a true negative. And then in the bottom left, we have a false negative, which is a type 2 error, where the person actually does have cancer in reality, but the model says they don't. And this is a very dangerous type of error because in this use case, the doctors won't even treat the person, won't even recommend any treatment plan because they'll think that the person doesn't have cancer and the cancer can grow and get worse. So both errors are not great and we want to avoid them. So the less errors our models make, the better. Now let's populate this matrix with actual figures. Let's say we have 100 patients. Out of them, our model made some predictions and we have 43 true negatives, 41 true positives, 12 type 1 errors or false positives, and 4 type 2 errors or false negatives. From this confusion matrix, we can calculate the following rates or ratios. We have the accuracy rate and the error rate. The accuracy rate is the total number of correct predictions, meaning the true negatives plus the true positives, divided by the total number of patients in this sample. So we have 84 divided by 100 or 84%. And the error rate is the total number of incorrect predictions, meaning the type 1 errors plus the type 2 errors. We have 16 of those divided by the total sample size, 100. So we have 16% error rate here. So those are 2 important rates to be able to calculate. So that's how the confusion matrix works. And as additional reading, I highly recommend checking out this article to have it handy for future use, where a person investigated the different forms of confusion matrix, because different tools, Python or any other tool that you might be using, can produce a different confusion matrix. So it's good to read through this so you always know which confusion matrix you're dealing with in specific instance. And in the tutorial, in our practical tutorials, you'll be dealing with the one that we discussed today and the one that's pictured here on the bottom right. So I hope you enjoyed this tutorial. I look forward to seeing you next time. Until then, enjoy machine learning.